Alright, we're going to do some inverse trigonometry today. If my trig ratio is the square root of 3 over 2, and I need to find the angle, given my unit circle, I can say, oh, look at that. That is my 30, 60, 90 triangle, and it's obvious to me that this is the pi by 3 rotation. However, there is a second evil angle that exists on this circle that has the same sine ratio, and it's in quadrant 2. And so I can see that one of my angles is pi by 3, and I can see that the other angle is 2/3 pi. Here we are with the second problem. Find the inverse cosine. Find the inverse cosine, or the arc cosine, of -1/2. And so there we go. I can rotate this around and I can see once again that this is 2/3 pi, and I can be very happy about that. But there is a second evil angle lurking in the third quadrant that also has that ratio. And so I have to pick up both of those. So I can see that this is 2/3 pi, and I can see that that's 3/3 plus another 1/3, 4/3 pi. And so those are my two answers for the inverse cosine. Now there are just a couple of notes about the notation that's important to notice here. I used this notation, cos, with a -1 above the cos, -1/2, meaning the inverse cosine. I could have also used this notation, arc cos of -1/2. However, this does not mean this, even though that would make sense. This means the inverse cosine. Second thing to notice is that these inverse trig relations are not functions for all real numbers. As you can see, the inverse, this is sine and the inverse sine. As you can see, this fails the vertical line test, and so instead we restrict the range. And so as you can see, we only use this tiny branch of the inverse sine function. That's why your calculator will only ever give you one value for sine.